Hello everyone, so I'm Mr. Zhang from Coco Education. In this video, we will discuss the solutions for question 16 to question 20. So for question 16, there are 4 players. Now for each game, the 2 points is awarded for the winner, 0 point for the loser, and if it's a draw, each player gets 1 point. So at the end of the tournament, no player has a perfect winning record. Now altogether, we have 6 games. This is 4C2. Each time you choose 2 players to have 1 game. So 4 times 3 over 2 times 1. This is 6 games. So each game, 2 points are awarded to the contestant. So 6 times 2. The total is 12 points. Now, no one gets a perfect winning record, so no one got 6 points. So this way, let's say the player who gets the most number of points is 5. It's because if it's 4 plus 3 plus 2 plus 1 is only 10. So the one who got the highest mark must be 5. The second player can be 4. For the last 2 players, we can let it be 2 and 1. Right, let's see if this works. So we draw a table. Okay, we have the player A, B, C, D. Then they play against A, B, C, D. And this is the total. Okay. So first we know that A can't play against A. Right, we cross out this. B cannot play against B. Same for C and D. Now, since A got 5 points, it will be 2 wins and 1 draw. Say when A play against B, this is a draw. When play against C is a win, play against D is a win. So this is 1 plus 2 plus 2, 5 points. So A play against B is a draw, then B play against A, this is the same game, so it's a draw. Now we want B to get 4 points. This is 1 point, so need another 3 points. So it will be 1 draw and 1 win. So B play against C is also a draw. C against A is a loss. We want C to be 2 points. So C against D is a draw. So D has 2 losses and 1 draw. 1 point. Okay, so 5-4-2-1, this works. So there are 3 draws here. First one is when A is against B. Then B against C. C against D. So the answer is 3. Question 17. So find the smallest value of n such that 4n minus 1 and 4n plus 1, they are not prime numbers. Let's list down the prime numbers. Now, first we know that 4n minus 1 and 4n plus 1, they are consecutive. Okay, so it has to be consecutive odd numbers, because there's only one even number that's prime, so that's 2. Then after that is 3, 5, 7, then 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79. The first time we have two consecutive numbers that's not prime is between 23 and 29. So we have the number 25 and 27. So let's try 4n minus 1 equals to 25. So 4n is 26. Right, n is not a whole number, n is 6.5. So this is wrong. Second time this happens is between the number 47 and 53. So we have the number 49 and 51. Then we can let 4n minus 1 equals to 49. Oh wait, before that we have another occurrence. It's between 31 and 37. So we check this one first. So 4n minus 1 equals to 33. So 4n equals to 34. N is 8.5. It's not whole number. Okay. For the next case, is between 47 and 53. So 4n minus 1 equals to 49. 4n is 50. 50 is not divisible by 4. This is 12.5. So it's not a whole number. Right. The next time when this happens is between 53 and 59. So we have the number 55 and 57. So let's say 4n minus 1 equals to 55. Then 4n equals to 56. Divided by 4, n is 14. This is the first integer solution, so n equals to 14. Question 18. Okay, to solve this question, first we connect this line and this straight line. So we will label this angle 1, angle 2, this angle 3, and angle 4. Then we always have angle 1 plus angle 2 equals to angle 3 plus angle 4. This is because the vertically opposite angles are the same. So sum of interior angles is 180. So these two, the sum equals to 3 and 4 added together. So we shift part of the x here, the 1 and 2, into the angle 3 and angle 4. Now you check for the outer layer. So the sum of these angles is 360. Then for the inner layer, we have a triangle. Sum of the interior angles here is 180. So let's add everything together. This for 1x we have 4 of them. So that's 4x. For 2x we have 3 of them. So plus 3 times 2x. The sum of angles is 360 plus 180. Those in the inner layer is 180. Okay, let me highlight the angles. So those from the outer layer, this is 360. So added together, 4x plus 6x, this 10x equals to 540. Divided by 10x equals to 54. Question 19. We have 3 green cards. Then we have the numbers 1, 2, and 3 written on them. Similarly, we have 3 red cards with the number 1, 2, and 3. So how many ways are there to arrange the 6 cards into a row? Adjacent cards have different colors and different numbers. Okay, let's check for different colors. So it can be red, green, red, green, red, green. Or you start with the green card first. So green, red, green, red, green, red. So to have different colors, there are 2 ways to arrange them. So let's say we start from the green cards. So if we only consider the 3 green cards, first one can be 1, 2, or 3, so 3 ways. Second card, we are left with 2 numbers, so 2 ways. Third card is 1 way. If you consider the green cards only, this is 6 ways. Then after that, we consider the red cards. Now, for any arrangement of the green cards, we'll say the arrangement of the red cards is unique. So let's see. So we arrange the green cards and the red cards in alternate order. So if the green cards is arranged as 1, 2, and 3. Now for the red cards. So the card between 1 and 2, it can't be 1 and it cannot be 2. So it can only be 3. For the card between 2 and 3, it can only be 1. So the last card can only be 2. You can have a different green card arrangement. Then you also see the red card arrangement is unique. So for the red card, there's only one arrangement for each case. So this is one way. So altogether, this is 2 times 6 times 1. 12 different ways. Question 20. Now n is the smallest positive integer such that 7n has 2021 digits. So we want this 2021 digit number to be as small as possible. So the first digit has to be 0. First digit is 1, followed by zeros. So only the last digit is not a 0. Let's say this is A. And this is 2021 digits. This is the number 7n. Let's rearrange it. Okay, so minus 7 for this number. Then all the digits will be 9 except for the last digit. This 2020 digits plus 7. Okay. So we separate a 7 from it, then we just check for this value. Now when you're checking for this value, we know that every 6-digit 9 is divisible by 7. This one divided by 7, remainder is 0. So we divide the 2020 digit number into group of 6. 2020 divided by 6, so equals to 336, remainder 4. There is 336 groups with a remainder of 4 digits. So we are left with the last 4 digits, 999B. Then we have to check this number divided by 7, there is no remainder. Okay, so now let's look for the value of B. So 9 divided by 7, remainder 2. Okay, then 29 divided by 7, this 4 times 7, 28, so remainder 1. 19 divided by 7, this is 2, so 14, remainder 5. Then we get a 5B here. So there's no remainder in the end, so it has to be 7 times 8, 56. This equals to remainder 0, so means B equals to 6. Right, so if B is 6, it's 996 plus 7, so 6 plus 7 is 13. The last digit here, so the A equals to 3. So 7 times n, this ends with digit 3. Then it can only be 7 times something ending with 9. Right? 7 times 9 is 63. So the n is ending with 9. The answer is 9.